Beautiful. Okay, yeah, so I don't have software development tools installed on my local computer. So this is coming to you for an iPad. What GitPod essentially is a developer environment that runs in the cloud. The IDE by default is VS Code, but that's very easy to switch out to do something like Emacs or Vim or JetBrains. It really doesn't matter. The best way to kind of look at it is kind of like CI/CD for developer environments. So when you're doing your day-to-day work, like you make a change to a branch, we compile that entire branch in the software and we build a developer environment. So then when you go review your pull request, you like click a button and then you review that pull request and the developer environment starts up instantly because you're not waiting for a pull requests to, not waiting for the software to compile because it's already been pre-compiled. So that's kind of GitPod, but that's beautiful. So that's kind of GitPod. I'm here today to kind of look at a more of a philosophical question, like what happens if the industry didn't use Docker, right? Just because something is popular doesn't mean it's good. Docker is good software. Don't get me wrong there. I'm not saying Docker isn't good software. I'm saying it came along and fixed a pain point in our industry, and that pain point was how to ship software and transport software. If we look at the internals of what Docker really is, it's essentially tarballs. Like all the individual layers and individual tarballs. It's a way of shipping software between co-workers and developers. But if we look at the first line in most Docker images, you'll see there's problems already on the first line on every single Docker file out there. And line one of a Docker file is sudo apt-get update. Like sudo apt-get update. Like you're probably thinking, like, what's wrong with sudo apt-get update? Well, it comes down to, as soon as you do that, you no longer have reproducibility of software. Like, sure, you can bake that Docker image and you can share that Docker image with a coworker, but if I do it today and you do it tomorrow to building that image, we're going to get two different binary artifacts that are not reproducible. So I'm going to start looking into some software that's been around for a very long time. Now, what I hope to show in showing this software is introducing you to something that I got into this about 2.5, 3 years ago. And the learning path for this is excessive. It is huge. There's a lot that needs to be done for accessibility. It's one of the reasons why it hasn't been adopted as much. But those that do know it and those who stick around, it's kind of like a wink, wink, nudge, nudge between senior engineers. And it's a lot of cool things are built upon it. So I'll be sharing up my screen very shortly. For now, it's just me. And because I'm on an iPad, this video side of things will be dropping out. So I'll start sharing up the screen and we'll get into it. So I'm going to walk you through Nix as a high level feature benefits, what Nix can do that Docker cannot. Now, Nix has been around now for, wow, almost 15, 18 years now. Like it's old school technology, but is really, really cool. All right, so I'm going to share up my screen. Let me know if you can see my screen, please. Start coming through any moment now.
Can see it now, yeah.
Yeah, it looks good.
Beautiful. Okay, so that's my abstract, and that's a quick introduction. I'm going to walk you through my personal monorepo. And everything in my personal monorepo is built from source, and every component from my software engineering stack, like for my applications to my infrastructure down to the Linux operating system, is all compiled from source, and it's all 100% hackable. If you think about the typical way that you would work in, say, with open source software, is you consuming binary releases. Here, I'm not going to be consuming binary releases. Everything's source code, but it doesn't have the downside of source code with Gentoo. And I'll get into that. But first, I mentioned before, traveling around Australia in a van. My website's ghuntley.com. Go check it out. And it's pretty sweet. So one of the things people typically ask about is like internet. How does internet work? So the good things is I have a blog post about that in the bottom left-hand corner. And on the average day, this is my office. I'm just traveling around in the van. So it's pretty damn sweet. Now, I mentioned YAML. If you haven't seen it, check out noyaml.com. It's a website that I made after doing one too many custom resource definitions. If you've ever done that before, you know the pain that it is. In case you're wondering, the website is deliberately not usable. It's an art project, so have a look at the beautiful reviews from reddit.com down the bottom there. And the talk itself is, the technology is Nix. If you want an easy introduction to Nix, I recommend checking out nix.dev. Nix.dev is a beautiful website that introduces you into the world of Nix, not from the programming language perspective, but more from the I need to do a task perspective. Like, I need to cross-compile my application. How do I do that? I need to build a Docker image. How can I do that? So Nix.dev is my #1 pro tip for learning, getting introduced to Nix. So, let's look at some fundamentals about Nix really quickly. If you think about how we build software today, is still based around these concepts from the 1980s. In the 1980s, we had computers, and these computers, mid-range and big iron computers, you used to have multiple users on a computer. And thus we had this notion of the file system hierarchy standard, the FHS. So the file system hierarchy standard is, the idea is like, you've got to elevate your permissions to install software, right? Because back in the day, we used to do, when we were doing software development or working on these computers, it wasn't just one person on a computer, it was like hundreds of people on a computer. So they introduced this idea of a file system hierarchy standard, and the idea was anything to do with home goes in home, and anything to do installing software required root access. This is where sudo comes in. If you think about when you install software on a computer, you have to run sudo apt-get install or sudo install. But as soon as you install it, what happens is you're installing that piece of software into the file system hierarchy standard, but you can only install a singular version of software. You can only install a singular version of software. So I'm going to be showing you an example of installing .NET, and showing an example of installing .NET side by side, 2 different versions of .NET side by side. And here, no sudo is used. There is no sudo at all. This matters a lot, because what happens is, with Nix, everything is, instead of being absolute paths with example of installing in like user/bin, etc. Nix rewrites the software, so everything is under a directory called Nixstore. I'll get into the particulars of that, but nix.dev will teach you the concepts. So first concept here is I'm going to show you GitPod with Nix. Right, so on github/gitpod.io/template.nix, this is the repository that I'm going to be showing, and you just mash that open in GitPod button, and you'll get a workspace. So I'm going to boot this workspace back up right now. And I'm going to actually search for a package, say .NET. So if you wanted to know the names of packages in the Nix ecosystem, you go to search.nixos.org. That's the place that you want to be. So if I search for this, I'm going to see .NET SDK 2 and .NET SDK 5. Right? If in the FHS world, like back from the 80s, the typical way, if you wanted to install a version of .NET, is you can only install a particular version. Pick your version. You're either going to install .2 or you're going to install .5. This is where Docker came into the world. Shipping software between people is really hard. How do we create environments that are reproducible? Well, Docker, it really isn't. It's kind of an abuse of the word. It's not really reproducible as such, but the proper definition of my definition of reproducibility of software. But what happens is when you build a Docker image, what you're essentially doing is you're just going like line 1, apt-get install, and then it goes for each one of those run phases, takes a file system kind of like a file system snapshot. And the end resulting of that file system snapshot, you get a tarball or a Docker image file, and that allows you to ship your software between developers, between servers, and all the rest. So at best, Docker is a encapsulation, and it was an encapsulation that our industry deeply needed, because we needed to lift the ecosystem away from the file system hierarchy standard. Because as soon as we install software into the computer, all of a sudden, then we've got this tight coupling of state with the particular computer. So Docker freed us from that, but it's not exactly the absolute best thing in the world. I'm going to show you something that is really cool. So this is the template Nix. This is the template Nix repository, and this is GitPod. I'm running on an iPad. All right, so I'm just going to duplicate the template Nix directory and call this .NET 3, and duplicate it again and call it .NET 5. All right. So there's a couple things here going on. You might see in that line there is the env-rc is blocked. Now, there's some really cool software called DRenv. Now, DRenv is a beautiful piece of software. If you've never used it before, it helps with building 12-factor based applications. The idea is you implement an env file, and that env file allows you to set environment variables when you go in and out of your directory. For example, setting authentication tokens, or if the environment is dev or prod. But there's something a lot of people didn't realize with DRenv. A lot of people are using DRenv, and that is DRenv was actually meant to be used with Nix. There's a special mode with DRenv, and I'm going to show you that special mode. So if I open up over here and look at my env-rc, it's got line 1 is use Nix. Use Nix essentially tells DRenv to invoke my shell.nix every time I go to bash, every time I go into a particular directory as part of my bash profile. So I'm going to show this to you. If I type .NET right now, .NET is not installed, completely not installed. And I'm going to install .NET. I'm going to install .NET by going into the directory. So what I've just done is I've blessed the current directory from a DRenv perspective. So anything that is defined, so what directory? I'm in the .NET 3 directory right now. Anything that's defined in my shell.nix here, anything that's defined in my shell.nix here is installed when I go in and out of that directory. So right now I haven't specified the package, and I'm going to specify the package of .NET SDK 2.1. Okay, sweet, let's do that. So I'm going to do .NET SDK, sweet. Now, I've blessed this nvar-c. If you notice, as I've exited Vim, it's actually reevaluating the shell.nix. And you'll see right down there, one of those lines is it's actually downloading the .NET SDK. So now I can do .NET version. Sorry, .NET version, or is it info? I always forget. So .NET version. And I go out of the directory and .NET version, .NET doesn't exist. But if I go back into .NET 3, .NET's installed, right? And I can go back down here to say .NET 5, and I can do the same magic trick. I can go here and go .NET SDK, was it SDK _5. I'm going to bless this directory, and that's going to reevaluate my shell.nix. So now my local file system, I have 2 folders, and those folders is .NET 3 and .NET 5. And when I go in and out of these folders, it's going to install and uninstall all the dependencies for my project. I go into .NET 5 and go .NET, and that is .NET 5, and I go out. Run info, I'm back at .NET 3. So at no point here did I use sudo at all. Sudo is not used. And what's something that I need to really point out here is, you probably weren't wondering, like, where is this magic trick? Where is .NET being installed? It's been installed under the Nix directory. And you're probably seeing like a content hash there, a content char there. I'll get into the specifics into the next tab of how that all works. But the main thing to call out here is .NET is probably more of a naive example. A better example would be Ruby or Python. See, the problem with Ruby and Python is often you have package managers like you got things like virtualenv, and you got RVM, etc. And those are only useful. Those are only useful if you're within that ecosystem. So if you are doing anything to do with Ruby and you want to compile Ruby gems, RVM is sweet, it works lovely. But as soon as you go outside of that ecosystem, especially in, say, Python, like C Python, or your dependencies in C, anytime you want to have a C dependency, all of a sudden you're in hell, because the package manager that you use, only handles the dependencies of Python, or package manager dependencies of Ruby. So with Nix, what it does is it actually installs all the dependencies for that you define in your shell.nix, or as part of your expression, side by side. So you can have multiple versions of .NET or multiple versions of like C Python, and each version of C Python can have its own custom version of OpenSSL or a custom version of ImageMagick, and they can all run side by side, exactly like I showed. And it's not an issue because it's not installing in the FHS standard, right? The typical way that you would get around this with Docker is you'd build 2 different Docker images. And that works all right. But if you kind of want to use that Docker image, then all of a sudden, if you're on Windows, you're essentially running virtual machines with Docker on WSL2. Well, it's a little bit less with WSL2, but on Mac, you're running Docker on Mac, you're essentially running your software through a virtual machine. It's quite slow. So anyway, that's off there on the tangent. So what I'm going to show you is that's the idea that you can side by side install software. So, but Nix is reproducible, meaning that when you specify software, like for example, when I was specifying here .NET, I can pin to a particular version of Linux or the NixOS operating system and the entire ecosystem to a particular version. And you can actually rebuild everything. You can actually rebuild everything to that particular version. So there's the R13Y. This is something you can't do with Docker. Like I started off with the narrative of saying Docker, you want to reproduce and build software. You can't. Line 1 is apt-get update, apt-get install. 2 co-workers, you can't reproduce the software. Reproducibility of software matters. And with Docker, we can't do that. Anyway, so anything that I'm showing you here can be used to generate Docker images. So Nix isn't, you don't have to go down this path and go, I want to do Nix or I want to do Docker. It's not like that. You can use both the ecosystems together. So I touched on it quickly, but Docker uses layers like the run one, etc. But the layering is very, very hard to do efficiently with Docker, because essentially it has no idea. When you do the run command, it's essentially doing file system snapshots between each one of those states. Whereas with Nix, what's essentially happening is it preserves the graph. And because it preserves the graph, you're able to generate very efficient and highly cacheable Docker images, like really, really, really good. Like a layer specifically, a layer just for Bash, for example, or a layer specifically for MySQL. And from there, that one particular version of that layer can be shared between all your infrastructure. So instead of duplicating, say, the binary size of MySQL in a Docker image in a layer across all your infrastructure, you just get a layer for that particular MySQL. You can do some pretty great things there. So if you want to get into that topic, optimizing Docker layers for better caching with Nix. Now, what I want to do is get back to the abstract. I promised that we'd walk you through my personal monorepo, where everything is built from source and every component, including the operating system, is 100% hackable without the developer experience with compilation from source. I'm going to show you source binary substitution. I've already quickly looked into how Nix is a little bit different to Docker. We touched in quickly of how to generate smaller Docker images from Nix, and that's the Graham Christensen blog. And we'll start heading towards how to deploy them onto your Kubernetes cluster. See, these expressions that I'm showing here can actually be served. There's this software called Nixory. And what Nixory does is it will take a Nix expression, say, for example, a shell.nix or my personal monorepo, and this actually works as a container registry. But it's a very special container registry. Like, you've never seen this before, have a look on line 1 there. It's going docker run nixory.dev shell/bash. What it's actually doing is you're actually passing in the Nix expression that you want to build, and it's custom generating a Docker image for you. So for me, when I'm deploying myself into a Kubernetes cluster, I run Nixory on top of my personal monorepo, what I'm going to get into. And so when I configure where it gets pulled from, it's actually not getting pulled from a container registry, it's getting pulled from my Nixory instance. And the Nixory instance will compile if need be, but it doesn't need to be compiled, because what's happening is I pre-compile the the expression and I ship it onto my Nixory instance. But if it didn't exist, it would compile it. So I'll quickly show it. Nixory.dev. Actually, for the sake of time, okay, it's booting up. Sweet. So I'm going to show you quickly Nixory.dev. So here we go. Docker run. There we go. Got a prefix there. So what this is going to do is I'm going to show you Nixory dev. So I'm specifying that I want a custom Docker image created. And in that Docker image, I want my shell, I want Git, I want htop, and bash. So that is going to connect to Nixory, and it's going to generate me my custom Docker image. So if you can envision that this was, say, a Kubernetes cluster, like, and this is my container registry, this is what this is actually behind the scenes what the Kubernetes cluster is pulling against. Now, I mentioned that optimizing layers for better caching with Nix, and this is what you're seeing right here. There's a lot of layers, and each one of those layers is super, super thin. And they're highly cacheable because typically you're going to have a singular version of bash used for your entire infrastructure when you're in the Nix ecosystem. Whereas in the Docker ecosystem, you would have multiple different versions of bash or multiple versions of OpenSSL or all the rest. And that creates all these issues when it comes to security. If you want to audit your Docker images, do you have, and when there's a security issue for, say, MySQL or like whatever, like a JSON parser, you have to audit your Docker images to see if it's all there. Under the Nix world, you have a singular that JSON parser is defined in a singular place, and then that's used everywhere across your entire infrastructure. And thus, here you got your you have this beautiful custom Docker image that's been served by my Nixory registry, and the end result here is, yeah, I've got a custom Docker image with Git, etc. So that's one aspect of it. So that's what I use as my container registry. To deploy into production, because I mentioned no YAML, is I use something called KubeNix. So KubeNix actually code generates from the resource definitions of Kubernetes. And I'm going to show you an example deployment. So in here, we've got our default.nix. And this is just defining entry points. In here is image.nix. And this is specifying the Docker image to build, because unfortunately, I can't inject a Nix expression directly into Kubernetes. But what I can do is inject a Docker image. So build layered image is this here, and I use it to serve it from Nixory, and the end result is that is my definition of my application that's being deployed into production. Now, Nix itself is built upon the operating system of NixOS. Well, actually, Nix is a package manager, and the package manager kept growing to the point where the package manager is also an operating system. Now, everything in NixOS is highly unit testable. There's a lot of integration tests. Everything is testable. It's one of the most tested operating systems there is. It's insanely good. And the reason why it's so good is because it's got these testing primitives built in. So right there on line 12, it's cube wait to succeed. So here I'm going to inject in my Docker image. I'm going to cube apply the Docker image. I'm going to check my deployment succeeded for my application. And this wait on succeed, etc. These are all NixOS or Nix primitives for testing. So this is how I actually do integration tests for my software. So I'd build an expression. The expression is the image. The image is served by Nixory, and that acts as my container registry. But before that all works, and it's pushed to the container registry, it runs through my integration test. And this is how I'm doing the integration test. At no point here am I using any YAML at all. There's no YAML being used at all. I have a single unifying programming language that unifies everything from deployment to my test scenarios to defining what my software is and how to build my software. So, mindful of time, let's walk you through my personal monorepo, because this is where some of the magic is. Okay, beautiful. So if you go to github.com/ghuntley, that's my GitHub repository. There's an open in GitPod button, and this will give you what you see here. Now, I'm going to walk you through the environment. So this is, I showed you template.nix. This is a scaled up version of template.nix. This is my developer environment. So no matter where I am on whichever devices, I am able to have a completely reproducible developer environment. And it's not just reproducible in the sense of like software reproducibility, but it scales into my team members. So I'm going to quickly show you something. So I've blessed this directory, and you've seen that it's done some software installation because it's blessed. Now, if I go into my bin directory, you're going to notice something in here. There's a whole bunch of symbolic links. Each one of those are all symbolic links to a dispatch script. Now, this dispatch script, and I'm going to explain and how all that works, is if I type, say, 7Z, 7Z was not installed before I ran that. What it's actually doing is it's now installing 7Z. And how that works, I'll get into unpacking. So Nix itself is a source-based distribution. Everything is built from source code. But if it evaluates the expression like nothing's changed, it will download it from the binary cache. And this is what's happening here. Now, 7Z is a naive example, but what's actually I'm doing here is by having these in this bin directory, in these symbolic links, is no matter who's in my team, they all going to get the same version of 7Z. But 7Z's a silly example. What about the AWS CLI? Right. So everyone here in my team is going to have the exact same version for their developer environment. So instead of pushing this all and building customer developer environments, this can be run from a CLI from any computer. It can run in GitPod, because GitPod is just essentially a place to host and run your code with VS Code on top. So I'm going to expand this and show you what's going on here. So if I expand in here, this link, the example I'm going to give you here is Vim, right? So in my terminal, I've got a symbolic link. I've got a symbolic link. So symbolic link to Vim. So I'm going to run Vim, and the first time I run it, oh, This is the problem with doing things live. What's going on here? Might have to talk through it. Okay, cool. I'm going to talk through it. Okay, so when I run Vim, what's essentially happening here is this attribute is go to my third-party directory. This is all a mono repo. And in this mono repo, and if I go into my default.nix and I go like, where is NVim or NeoVim? NeoVim is here on line 77. Line 77, you're seeing that it's inheriting into Nix packages. And you're probably wondering like, where is Nix packages? So in bin here, lsltr, and have a look at NeoVim. So NeoVim invokes the dispatch script. The dispatch script invokes my third party, the third party. Then this is where the single source of truth in all my software for my entire mono repo, there's a single version of NeoVim. And that's coming from Nix packages on line 74. So I go up, it's like, where is that coming from? Where is that coming from? That's coming from line 20. That's being imported from the file system. Now, I'll give you a scenario here. Is like when I run NVim, remember I mentioned that it evaluated the expression. And because there's maybe no changes to the expression, it's downloaded the binary of a binary. So if I expand over here and go into GitHub, go into NixOS, and go into packages, and then head into applications, and go into editors, and then head all the way down here to NeoVim, to NVim or NeoVim. This is the source of truth. This is the build definition of Vim. This is coming from NixOS. And remember, NixOS and Nix, they're both really orthogonal to each other. So here's a scenario. All right. So right now, when I type NeoVim, which is not working, I'll have to figure out later what's going on there. What's happening is it's evaluating the expression. And now that expression has been evaluated, it's seen that there's been no changes made to it. So it's going to download from the binary artifact, binary cache. And this binary cache can be, like for here, it's using cache.nixes.org, but that could be a team-based cache. You can have you run your own private cache. There's actually software called Cachix that allow you to host your own private binary cache that can be shared between team members. So in that case, what you do is you publish that software. You publish that software via your CI/CD server, and that's similar to what I do. I build, and then I publish the build artifacts to Cachix, and then that's consumed by my Nixory instance. Anyway, so let's say there's been a security issue in your infrastructure, and you need to do a custom version of Vim. You need to monkey patch Vim. You can't wait for Ubuntu to release the security updates. You need to release a new version of Vim right now. In the Docker world and the current world that exists right now, there's nothing you can do. You got to wait for the open source maintainer or the vendors to release updates. In the Nix world, because everything is built from source, this is your build definitions. You can go, yeah, I just want to use Vim. I just want to do the next version of Vim, or I want to head down here into my build definition for my thing. I can go echo temp plus allow. So that's an example, like applying a patch file. So I can hack from my IDE here in GitPod. I can hack on low-level dependencies. So I'm using Vim as a silly example, but this could be OpenSSL. It could be the Rust compiler, right? And then let's say it's Rust. As a result of me changing Rust, at the top here, in the build definition, I'm defining a single source of truth, right up here. So say it's libuv, and I need to hack on a custom version libuv. When I make that one change and I submit my job into CI/CD, it actually will rebuild my entire infrastructure from everything down from machines to Docker images to my applications, and does verification pass with my tests that that change to the libuv didn't break anything at my high level application level. So what I'm getting at is I've got complete control. Typically in the Docker world, you don't have complete control of your software supply chain. Here I do. So because I've made changes to this expression, if I was to run Vim again, it would actually download the source of Vim and actually do a compilation. And so with that in mind, and because I'll have to figure out what is going wrong with my demo, I'm going to switch over to questions because I'm mindful of time. Nix is really special. Roles with Nix are rare as hen's teeth. If you can find them, you're going to find a company that's doing something very interesting in the ecosystem. Nix is not something that you learn because you want to get the next shiny. Nix is not something you learn because you want to get the next shiny job in the IT ecosystem. It's something you learn because it's kind of like master tree. It's like knitting software. It's beautiful. But Nix.dev. If anyone ever wants to catch up and talk about Nix, I'm happy to show what I've shown in person again and help out. But yeah, open to questions.
Awesome. Well, thanks a lot for the presentation. We did have some, like you already answered one of those, but someone asks how to build configuration for custom images. Yeah.
Yeah. So to building custom images, there's an expression called build.docker.layer image. It's part of the built-in with Nix. But if you have a look at Graham Christensen's blog, cacheable Docker images with Nix, that will get into how the graph is much better way of building a Docker image versus file system snapshots as used by Docker.
Cool. Awesome. Well, thanks a lot for sharing. And Hannah asks, is this something you can utilize within an enterprise?
Probably not, to be honest.
Cool.
It's something that you like. Yeah, maybe you could use it in an enterprise, but depends what's the enterprise. This is a tool that's kind of like passed around by word of mouth by principal engineers to other principal engineers, and because it fundamentally fixes a lot of problems that we have in the industry. It's used for bespoke purposes. Like, yes, you can use it enterprise, but the knowledge isn't there yet. When you first getting into it, you're like, oh, I just want to do this, and you're going to hit these walls, massive walls, and those walls prevent adoption. And it's only until we get more people talking about it, like as we are now, more people playing with it, working on the documentation. It's not a great experience currently, but it's getting better. It needs to be taught. It needs to be shown. It needs to be introduced slowly. It needs to be worked with the benefits. But if it's like, oh, you're using Nix and you want to just join in, people are just going to scream, because with Docker, they can just apt-get update and generate a custom Docker image. So yes, you can use it in industry, but the question is, and enterprise, but the question is, what enterprise are you using it? Companies such as, like, before GitPod, there was AWS Cloud9 as a custom cloud IDE. Cloud9 is built upon Nix. Core infrastructure of Shopify is Nix. A lot of the stuff you're using in the Web3 market with crypto is all powered by Nix. It's used in banks. It's used all over the place. But it's very much a word of mouth technology. It didn't have Docker succeeded because it had a lot of venture capital money injection into marketing. Good technology because it's good technology because it exists and you know about it doesn't necessarily mean it's good technology, right? It just could mean that it just had a very large marketing budget. And Docker fixed a lot of problems in our industry, but at the same time, it's just an encapsulation layer, and it was very hyped, very, very hyped, and there was a large amount of money injected into the ecosystem, so you know about it.
Awesome, cool. Well, thanks a lot for sharing, Geoff. There's one last question. Offer asks, will Gitpod support CI/CD and will it support headless, that is development environment without an IDE?
Yeah, so a couple of things. I suppose there's not enough context to really be able to understand that correctly. We do CI/CD. But the CI/CD we do is we pre-compile your developer environment. So if I'll give you a good example, say you've got a web application. Say you got a web application. Typically, you would part of compiling that web application, you have to do a yarn install. But that yarn install might have C dependencies. So those C dependencies would need to be compiled if they're not already there. That could take some time. So say you're reviewing a pull request from a fresh state. You would have to wait for that compilation time to happen, that package restore time to happen. If that was on your local computer and you're like me, you're camping in the middle of nowhere, each one of those HTTP requests has a high degree of network latency, large amount of network round trips. But whereas with Gitpod, essentially your data center is your developer environment. So I can be running on a very marginal internet connection and all those dependencies installed in the Google Cloud. But with Gitpod, getting back to it with CI/CD, is we can pre-compile the application, we pre-compile the installing the dependencies to build your developer environment. And that's what the line is, developer environment. We're not a platform for validating that your changes work to know if you can merge a pull request, right? At the end of the day, what Gitpod essentially is give us a Docker file and we will host it in the cloud for you, and an overlaid VS Code on top, or you can do Vim or Emacs. Give us a Docker file and we'll host it and run it. So your typical CI/CD scenario still exists, because what you do is you would build the Docker image, right? And then you validate that Docker image and use the same Docker image, hopefully, that you use in development as you do in production, hopefully.